Let's talk about nomenclature. Nomenclature is a method or rules for naming compounds. It was developed by IUPAC and didn't occur until almost the 1900s. Prior to this, common names were used, which is why we have old names like vinegar or acetic acid instead of ethanoic acid and grain alcohol instead of ethanol. Those old names are still used a lot today. But before we can learn any of these IUPAC rules, you need to have the names and structures of 10 kill groups memorized. So these are the ones that I asked you to memorize the other day. So they shouldn't be anything new to you. This is 1 to 10 carbons. The first four are the ones that get tricky. Remember, I said meet Ethan, professional, butler. And then from there, they make a lot of sense. Pent, hex, hept, oct, non, and dec. So make sure you get those memorized before you try to do anything else with naming because we're going to use those. Now I want to point out to you those are the alkanes. The name of the alkyl group ends in YL, right? So methyl is taking the word methane and replacing the ANE with YL. So those are the alkyl groups, right? Carbons are classified according to the number of other carbon atoms in which they're attached. This isn't too important, but it helps you with kind of old nomenclature. So a primary carbon will have just one other carbon attached. A secondary carbon has two other carbons attached, and a tertiary carbon has three other carbons attached. So primary, secondary, tertiary. Okay, so to make the alkyl group, we're just going to remove one of these hydrogens and you're left for it as a alkyl group ready to attach. Okay, so methane is CH4 and the methyl group is CH3 ready to attach somewhere. For ethane, all six hydrogens are equivalent, so pretty much any of those hydrogens can attach in. Removing one hydrogen is going to generate the ethyl group. It doesn't matter which one you remove. And I'm only mentioning this because, again, this goes into kind of an older system of nomenclature that's going to be important that uses this primary, secondary, and tertiary. Okay. Um, I'm never going to test you on ISO and SEC, but I just wanted you to be familiar with those just in case you ever saw them. Okay. Primary ISO and SEC are secondary groups. Okay. And I'll show you some examples of those right here. Right. This is isopropyl, and you can see here iso is that secondary group here when it's a propyl, but iso is a primary group when it's a butyl. So again, I don't go into these, and this is tert for tertiary, tert butyl. We're going to learn IUPAC in here. I just wanted to throw them out there in case you wondered where those came from. Isobutane can give rise to isobutyl or tert butyl. Um, don't worry about this as much. We're not going to do those. But this is what we're going to do. IUPAC names for alkanes, okay? The base or parent name for an alkane is determined by the longest chain of carbon atoms, the longest continuous chain. And it's really important to remember that that chain may bend, it may twist, and it says here it's seldom horizontal. That's because we love to trick you in questions like that. Any carbon groups not part of the base chain are called branches, or another word is substituents. Okay? And then these carbon groups are also called alkyl groups, and that's where we get those names from. So let's practice here. Rule one applied. It says find the longest chain in each molecule. So I want to show you right away that your eyes are going to go here. Okay, that's just, we've been taught to read left to right our whole lives, so your eyes are going to go right there. That is wrong. That is not the longest continuous chain of carbons. You need to go here to find it. Now you might be wondering, well, why did you go up here? Could you not have gone 1, 2, 3, 4, 5, 6, 7? Could you have gone there? Well, no, because that won't give you 8, right? 1, 2, 3, 4, 5, 6, 7, 8. You've got to find the longest chain. And here's the longest chain here. 1, 2, 3, 4, 5, 6, 7. Okay, so this one that is 8 carbons is an octane, and the one that's 7 carbons is a heptane. That's the longest continuous carbon chain. So step number 1 is find the longest chain. Step number 2 is number the carbons in that chain. And you don't want to number them from left to right. Notice there's nothing that's how we read. Nothing says left to right. Instead, you're going to number the carbon atoms in the chain, starting from the end with the first branch. So again, we say 1, 2, 3, 4. And there's a branch. All right. Or we can go 1, 2, 3, and then there's a branch. So we want that branch to come sooner, so that's what we're going to go with. 1, 2, 3, 4, 5, 6, 7, 8. Notice that it doesn't go left to right. You have to number them where they branch earliest. Same thing here. 1, 2, 3, 4, 5, and a branch. 1, 2, 3, and a branch. So that's the direction that we're going to go in for that one. If both branches are equal from the ends, you're going to continue looking for differences in nomenclatures having to do with alphabetical order and things we'll talk about in a second. Then I like to circle the substituents. So in this example, if I were to look for my continuous carbon chain, 1, 2, 3, 4, 5, 6. Here's a substituent here and a substituent here. Okay, so this red one right here, this is an ethyl group, and the blue one is called a methyl group. So you're going to write them where they are numbered. Remember, we counted 1, 2, there was a branch. Okay, so it's a 4 ethyl, 2 methyl, and this whole thing has 6 carbons. So this whole thing is called a hexane. A couple things about the way that we write it. We usually write the halogens first, but that's because the halogens come in alphabetical order first. That's what we're really doing. We're putting them in alphabetical order. And ethyl comes before methyl. And then we're going to indicate the position of the branch in the main chain by prefixing its name with the carbon number to which it's attached. So 4 is telling me that it's at location 4, while 2 is telling me that the methyl group is at location 2. Separate numbers and letters with a hyphen and separate 2 or more numbers with commas. And you're going to have to type these into Schoology, so you'll get used to those. When a branch or substituent occurs more than once, we need to use a prefix. Okay, prefixes di, tri, tetra, they should sound familiar here. I'm going to count 1, 2, 3, 4, 5, 6, 7. All right, just to prove to you that this would work, if I did 1, 2, 3, 4, 5, 6, 7, I'm going to go ahead and leave that like that. So again, here are the methyl groups, and here is an ethyl group. Okay, so we have an ethyl group at number 1, 2, 3, 4, 5. Okay, so number 5 has an ethyl. And then at carbon number 2 and carbon number 3, we have a methyl group. And we call that a dimethyl because there are two of them. Now notice just because I added di, it doesn't change the alphabetical order. I'm still doing M versus E, okay? So ethyl comes before dimethyl. Okay, so that's branches using di, and then there would be tri and tetra. And don't forget, if you've got a tri, you're gonna have more than one comma in there. So it has to be telling you exactly where they are. So let's practice this from beginning to end, okay? First, I find my longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I know right away that this is going to be a decane. Then I'm gonna number it. So 1, 2, 3, that's where it branches first. 4, 5, 6, 7, 8, 9, 10. Next, I find my substituents. In this case, they have two methyls here. That's the 3,3, because they're both coming off of carbon 3. You need to have two numbers. If you have a di, 3,3 dimethyl. And then there's just one ethyl group. It's coming off of carbon number 6. And ethyl comes before methyl alphabetically. Another thing I want to point out to you is there's not a space here. There's no space. So when you type that in and you type these big long names into the computer, there's no spaces. Here's these alkyl halides. These are alkanes bearing halogen substitutes. Okay, so here is a chloromethane and a fluoroethane. Notice it doesn't say one fluoroethane, because if I were to follow the rules and I were to count my carbons there, of course it would branch at number 1. It can't branch at carbon number 2 because I'm trying to branch it at the lowest number possible. And chemists are lazy. So this is not fluoro-1-ethane. It's just, or I'm sorry, it's not one fluoroethane. It's just fluoroethane. Now this one, two, 3 carbons. I could have the iodine off of carbon number 1, or in this case, it is off of carbon number 2. So the name of this is 2-iodo. Sorry, I didn't mean to put a dash there. 2-iodopropane is the name of this guy. This one, love the way they wrote it, quote, backwards there. So please don't put 3, carbon 1, carbon 2, 3, and then 4. So this is a 2-bromo, and then it's 4 carbons. So this is a 2-bromobutane. And then this one, the way that they've shown it here is 1, 2, 3. And off of this group here, we have a methyl. So we have a 2-bromo, 2-methyl, and this whole thing is 3 carbons, so it's called a propane. So a 2-bromo, 2-methyl propane. B comes before M in the alphabet. Now we can go back the other way, right? We're going to have to draw them from the names. So we've got hexane at the end, which means we're going to start with our 6-carbon parent chain. The next step is to add those substituents. In this case, it's bromine and a methyl group at carbon number 1 and carbon number 4. I'll be honest with you, usually at this point you are reading left to right. It's just what you're used to. And then you want to add in all the other hydrogen atoms to complete the structure. So this one is 1-bromo 4-methyl hexane. Okay, let's practice here. We've got our formula drawn. Now let's condense it, right? So the condensed formula looks like this. but we can write it um, bromine. If you want to put it into brackets, you can. CH um, 2, CH2, CH2, CH. CH3 goes into parentheses, CH2, and CH2 at the end there. So hopefully that gives you some practice in naming, and there is lots of practice for you.